Okay, another day, another video. Today we are going to get an introduction to Vapor, the Swift server-side framework. I'm going to make this a two-part video series. This first video is basically going to be an introduction, so we're going to do some routing and learn about the FluentORM. And then the second video, I'm going to convert the server that we create into a GraphQL API service. So I'm going to assume you guys can install Vapor on your own. I'm not going to bother going through that. It's pretty easy to do. Once you have it installed, you want to create the project. So I'm going to call it this. And then it's going to ask if you want Fluent. My database is going to be Postgres. So this will open it up. Don't know why, but sometimes the packages downloads takes a really long time, and sometimes it's pretty fast. But okay, so as you can see, we have our project. The folder structure is there. Before I get into it, I want to talk about a couple of things in terms of the underlying design and architecture of Vapor. So Vapor is a lot like Node and Express. Underneath the covers, Vapor is using a library created by Apple called SwiftNeo. And SwiftNeo is an event loop based asynchronous I/O capable library. So the Vapor team is basically reusing a lot of that functionality to create a web server. So if you know anything about Node and Express, that's basically the same thing, right? So you have Node is a runtime that among its capabilities, it has an event loop based system for doing asynchronous basically processing, and Express is a wrapper around that. So you can think of Vapor as pretty much the same thing. Vapor to Express and SwiftNeo to Node. So as I said, Vapor is event loop based, and the main two constructs of this system are the event loop future and the event loop promise. So in JavaScript, you have only a single asynchronous object called the promise, and it will either succeed or fail, and then in either case, it will bring back a payload to the function or code that has received the promise. So it works. This system works pretty much the same way, but it actually has two object types. One is the event loop promise, and the other one is the event loop future. So the event loop promise is basically a lot like the promise in JavaScript. It is the processor. So you have some code, you're wanting to do it asynchronously, and then at the end, the promise you will use the promise to determine whether that activity was successful or whether it failed. And then let me just write it out so it'll make more sense. So off of the request object, you're going to have the event loop. And then off of the event loop, you're able to create the promise. And it's going to be of type whatever you're returning. And then when you return, you actually don't return the promise, you return the future result, which again in this case is this. So basically what I think this architecture is it's basically a pub sub, but object based. And the pub or the publisher is the promise, and it basically publishes the results, and then the subscriber is a event loop future. So if you want to think about it purely conceptually, the analogy that I use in my own mind is a company giving out a corporate cell phone. So the company may send the employee out to the field with a corporate cell phone and tell the employee to wait until they get a call because the home office has to do some work first or has to sign a contract or whatever it is that they need to do. And then once that work is done, the employee will be notified either through a text or a voice call on the phone. So you can think of the event loop promise as the corporate headquarters and the event loop future as the phone. So anyway, continuing on. So if we pretend that some work was done and that it was successful, so this is going to be success. There's also a fail. But let's pretend everything was successful. And I'm going to try to run this. So as you can see, the promise was created from the event loop, which is coming off of SwiftNeo again. And then we pretended that whatever processing happened here was successful, and we sent back the payload, right? And this is, of course, going to be happening inside of some asynchronous activity in here. And then this event loop future of payload string is returned immediately. It doesn't wait around for the asynchronous processing. But like I said in the phone example, although the guy got the phone, the employee got the phone immediately, he didn't get the call until the processing work was completed. So that's basically what happened here. So I'm bringing that up because you're going to see this event loop future a lot, especially when we use the Fluent ORM to access the database. But so this is very important to be familiar with. So then the other thing to know at a very low level is there are 3 ways to receive parameters for a Vapor call. So the first one is going to be through query strings. So let's get rid of this. So as you can see, this is a get call. This, as you just saw here in this sample URL, it's the sub URL after the domain. So we don't have any specific parameters, but I'm going to create a query string. So again, we use this, and then we go to the query object, and then we grab this query string variable, and then let's pretend that going to stick it in here into the core message that's being returned. And then I'll reload. Okay, so I'll reload. So this time it's going to be a query string. It's going to be message. And there it is. So this is how you access the parameter if it were a query string. And then the other ones are pretty similar. So in the case of parameters, it's going to be so what this means is it's being passed in on the URL, not as a query string, but as like a subdomain value. So that succeeded. Going to reload again. So that reloaded, as you can see down here on the bottom right. And then, like I said, it's not a query string. It's like a subdomain parameter. Let's try a different name. Okay. So that's the second method. And then this one, I'm just going to copy and paste it. So this one is going to be a post. So it's going to use the body parameter. And I didn't want to get into this now, but let's just do that real quick. So this video is going to be about basically a sample application that's like a to-do app. So the reason why I'm creating this is when you are receiving parameters, really anything that needs to be decoded or encoded, then you would inherit from this content protocol and then do whatever you need, add whatever fields you need to add. So that's why I needed to show that, and I'll explain later why this is a DTO. But just to focus on the main thing, which is to take parameters from a postback. So I'm going to reload this, and then once again it finished reloading. So this time, because this is going to be a post, we're not going to do it off the browser. I'm just going to use this curl call. So you saw before I had a title and a description field, and this is a JSON request, as you can see here, and it's a postback. So I'm only getting the title. I'm only putting back the title, but basically what's going on here is, you know, it's not called body. First, there is a body object here, but it doesn't grab it from the thing called body. It grabs it from the thing called content, and then it decodes it of type to do DTO type. The reason why it uses type is because it needs access to the init, which obviously cannot get from the object instance. So then it converts it from JSON into an actual object. because of course Swift is statically typed, so we need that. And this is the previous code to create our promise. And here I'm just printing out right here the to-do parameter. And then I say I succeeded, only grabbing the title. And then once again, I return it. So let's just see that again. So right here, that's that coming back. So this was pretty fast, I know, but at the same time, these are kind of bread and butter functionality and features of Vapor, the promises and the event loop. Like I said, most of the time you're not going to create promises yourself, especially if you're using the Fluent API. You're just going to be getting back event loops with whatever the payload is. But nevertheless, the event loop is coming from a promise, so it's good to be aware. And then the 3 different ways of receiving parameters from the URL. So, so now that we've kind of seen at a very basic level how Vapor works, let's look at the project files themselves. So one of the really nice things about Vapor is that a lot of the typical sort of activities that you would do are built in out of the box. So for example, in any production app, you're never gonna hard code passwords and IP addresses and stuff like that to servers, in your code, right? So it has built-in capability to read a .env file, to load it up, and to run the configuration based on that file. So part of the work of the bootstrapper is to do that, and then finally to run the server application. So I have a pre-made one. I'm gonna copy that. All right, so I've copied the file over. So obviously your file is going to have your own IP addresses and all that stuff. And I've gone ahead and updated the variable names to match the file. So this is the bootstrapper that kicks off the server and reads the configurations and supplies them to the application. The first thing that we have to do before we can actually move on is we have to set up our database. Now, because we're using the FluentORM, it can, based upon the code that we provide in the migration, which is inside of this guy, it can create our database tables and fields for us. So in this case, oh, and also I want to be clear on this. So we have a model file. And by the way, this is coming out of the box. You don't have to inherit from content in order to create a model. You just need to inherit from model. But it's here because I guess they're assuming that you might use it as a parameter. But this model, although it's going to be mapped to the database and it has to align in terms of its fields and the table name, it actually does not have any impact as far as the migration is concerned for creating the table and the fields. Only the migration itself, which is done by a struct or a class inheriting from migration, and specifically in this function, only what happens in here is what impacts the actual migration and creation of the tables. So I just wanted to make that clear. So we're going to update this file. We're going to, I just want to show you the database first. So everything is going to go in this Postgres database. As you can see right now, there's nothing in here as far as tables are concerned. So I prefer caps, so we're going to do that. And let me make sure everything is matching. And I'll explain these property wrappers in a bit. So, like I said, this prepare function is coming off of the database. It's going to generate a table, and that table is going to start with an ID of primary key of type UUID, and you get all of that from this one call. And then you have the field name, you have the type, which we're not going to use string because I found that string actually makes the type text, and for such a small title, I don't think that makes sense, so we're just going to use varchar. And then required, of course, makes it a required field. So let's just copy and paste these in. So we need a description for our to-do. Descriptions are not required, so I'm not going to have that. Now, I'm adding fields that are not in the model. And again, that's fine until we start using the model because the model is not tied to the migration. So what I'm doing here is adding a relationship. So we're going to create this user model and migration as well, but that'll have to wait until I finish this section. So when you're building a relation, you indicate the type for the field in the other table. And since it's the primary key, it's always going to be required. The third set of parameters is, I forget the Swift nomenclature, but basically you can keep adding more and more constraints going out. So we're going to add the constraint for the relationship. So it's going to be to the users table, and it's going to be on the field ID because we're going to use the same mechanism as here. And then I'm just going to copy and paste this code. I'm going to add some auditing fields. So these fields are going to be the same in users as in to-do, and it's going to be the created by, which is going to be required, the last modified by also required, date time, and I'll show you when I create the model, but basically it's going to become a timestamp. And when you indicate at the model via the property wrapper that it is a timestamp, these will get auto-populated. So these are not being auto-populated, so we'll have to populate them ourselves. So I just want to make sure this compiles. All right, so then we'll go to the to-do. So I already updated the field names. So this is going to be the description, and it's going to be optional. So we're going to use optional field. So we're going to have that. And then we wanted to have that user relationship in our to-do. So we want to have an owner of every to-do. So you do that by referencing parent. And So this user ID obviously matches the one in the migration, which is going to be an actual field in the table. The opposite side of this, which is called children, that's going to be in the users model, is actually, because this is a one-to-many relationship, it won't end up being in the users table. Okay, we didn't create this yet, so. All right, so these are just boilerplate. I'm going to copy and paste these from my code. So obviously these are lining up to the audit fields that we just created in the migration. Again, if you notice that in the migration and therefore in the table, these are required, and yet in our model, they're not required. And like I said, you can do the model however way you please. If the model ends up being a content and you want to pass it in through your parameters, you may not want to fill in these fields on the client side. You might want to fill them in after you receive them from the client. Let's say you only want the client to provide the title and the description. So, you can still use this as a parameter object, and then inside of your code on the server, you can populate these two at a later time. As I said before, these will auto-populate because they are timestamps. So this default constructor is required. Internally, Vapor is using it, so that's why we have that. I'm just going to copy and paste a convenience initializer because again, it's just boilerplate stuff. Actually, this we don't need. Whoops, too soon. Okay, I'm gonna have to compile this in a bit, but so basically you can see everything that's happening here. These guys I'm auto-populating as the app, so we know that this to-do was inserted from the application as opposed to, say, some batch script or some other process. So that's why I have these set to app. These up here are obviously fields from the object type. This, if you notice, is nullable. So the reason why this is nullable on the model, again, even though it's not, because this is a primary key, it's not nullable, is because Vapor allows us to create this object without an ID. And then when it comes time to save it in the database, it will auto-generate a UUID for us. So this is only true in the case of UUIDs. It doesn't help us out if it's like an int or a big int or whatever. This code right here is happening because this is a property wrapper, so we can't use this directly. We need the $sign, and then we only need to populate the ID to make the association. Vapor is gonna know what to do with the rest of the data if it is needed, meaning later if we call user dot username or whatever the field is. Okay, so now I'm going to create the user model, and this is going to be pretty much boilerplate code, so I'm just going to copy and paste it. So just remember you're going to need a couple of new imports. Again, you don't need this just to create a model. You do need this. I actually forgot to talk about this on the to-do. But basically, you do need this because it references the table that this user is associated to. So then we have the same thing we had in the to-do. And then, of course, the username. That's really the only thing that's going to be in our table other than our audits. And this relationship, like I mentioned, is based on the children property and then the user field inside of to-do. So this is referencing the to-do object and its property wrapper user. And this entry will not appear in the database, in the user database. So we have the exact same fields for auditing. We have this necessary default constructor. And then here we're just setting the ID and the username because there really isn't all that much to the user. So then we need to create a create user file. So this is going to be pretty much identical, not the same fields, but the same methodology as to do. So we have our schema table name, the primary ID. We're using, again, varchars instead of .string. Custom means you can put any valid SQL syntax in here. Obviously, as long as it makes sense within the context. And then we have our auditing fields. By the way, this create is when you want to create a brand new table. There is also an update that you can use to modify, but we're not going to use that. Yeah, so it's basically the same stuff we did in the create to do. So let's try compiling. So that was successful. Okay, so we need to execute our migration, but I realized that I had some bugs in the create to do. I wasn't closing the parentheses over here, so you might want to double check that. And then if you go to the configure, we need to add the create user migration on top because to do is having a reference to user. So I did all those changes, and then we can run the migration. So you run it from the command line like this. If you're running it for the first time, it will take a while to set up, but I've run it several times before. So it says the migration was successful, which means that we should see our two tables. So you can see our reference is in the to-do, but no reference in the users. Okay, so the next thing we need to take a look at is routing and models. So obviously we already went through this where we're looking at the route and we're looking at the result. For sample purposes, I only returned a string, but we have our models and we can return the models from the URLs, but we could also accept models or data transfer objects as parameters. Now, whichever method you use, whether you want to take your model and reuse it to become a parameter for a route, or you want to use a DTO, you have to inherit from content so that when it shows up in the parameters list from a postback, it is decodable. So obviously it's possible to do routes in this manner, but a better design for larger applications is going to be to use a controller. So when using a controller, I just need to explain how the mechanism works. First, obviously, you have to inherit from route collection, which ToDo controller does. And then the beginning or the initializer is this boot function. And basically, the very first thing you do is you create this grouping for your specific controller. Now, this grouping is actually a sub route. It's a sub URL off of the domain, as well as being a label for your group. So just be aware of that. And then once you create that subdomain or sub URL, then you can add your HTTP methods to it. So in this case, the methods are being associated to these functions. And internally, the functions are using Fluent to access the Postgres database. Now, this guy right here is an additional grouping, and therefore it's an additional subdomain or sub URL, I mean. And when you see a colon, it just indicates that this is actually a parameter. So in this case, you would have HTTP, the domain / todos, then / some parameter, which is going to be called ToDo ID. So in this case, it's doing a deletion. And this is the code that's coming off of the template project. So we're not going to need a delete, but it's there as part of the template. Okay. So let's update this create to try and work in the way that we want. So in the case of our data model, we actually have two models, the user and the to-do. And the user is the owner of the to-do and referenced by the to-do. So in order to create a new to-do, we do have to get the user object off the database first, and then we can create the to-do, and then if we want to, we can return it. So as I was mentioning before, it's possible to use a DTO, a data transfer object, to receive as a parameter instead of your actual model. If you want to use the model, you can just, in either case, inherit from content. But because our model for the to-do is, has various fields in it that are probably not going to be sent by the client. In our case, the client is just going to be sending the title and the description, and the rest of this stuff is just not going to be used at all. So it's not, how should I say? It's not a best practice to do that. So in this example case, we're going to use a DTO. And let me just show you the DTO one more time. So again, you need to inherit from content. That's what makes it decodable. I believe internally there's a decodable that content inherits off of. And then again, we're just going to send the two fields. So we do the decode, and then we send the type that we want to decode off of. And we're sending the to-do DTO type so that this guy can get access to the constructor internally. And then we're going to, like I said, need to get the user object first so we can associate it to the new to-do that we're trying to create. So this query is going to need the database object to access it, and that can be had off of the request object, so it's always available in there. And then we are doing a filter, and then the filter is going to take the field of the current instance, and we're going to take the property wrapper username, and we're going to compare it to, in this case, we're just going to compare it to John. We're going to hard code it to John. And by the way, I already created an entry for a single username John. So just for demo purposes, I'm going to hard code the filter to look for John. And then there's only one user and we only want one user. So we're going to take the first result and we're going to try and unwrap it. Because these results are not nullable, we're going to abort. We're going to throw an exception if we find nothing. So it's either going to unwrap or it's going to completely fail. So there's a couple of different, how should I say, methods to generating this event loop future. One of them is where you can just do a map, and then that's going to be one-to-one. So it's going to generate a new event loop future from some prior event loop future. In the case of a flat map, it's going to take something that could look like this. And so on, and then it's just going to flatten it down to a single. So that's what the flat map does. So in this case, we're trying to create a new to-do. So we're going to create a new instance. And then off of that new instance, we can try and create it. And I'll try and compile. So that was successful. So before moving on, I want to explain something about Fluent. So there's three basic ways that you can query the database. So you can query off of the main database object. So we haven't done that, but it's possible to do that. You just need to pass the appropriate model, the specific model that you're trying to query off of, and then you can do your query that way. You can also query off of the type, the model type, and we had already done that right here. And then for certain specific tasks, you can query off of the instance, right? But if you're querying off of the instance, then only certain things that make sense would become available. So creating a new instance obviously makes sense. So saving an existing instance is also possible. And just be aware, saving a newly created instance is doing the same exact thing as create. So just be aware of that. Okay, so that's the only change that I wanted to make here. And then since we are having another model, we're going to create another controller. And in the case of the user controller, we don't have anything pre-created for us. So I'm going to create the whole thing myself. So this is obviously for the Fluent API, and then certain things like the route collection or other protocols that you may need would be coming off of Vapor. So again, the first thing you need to do is create the bootstrapper, basically the initializer. So we are going to create a new group just for users. And again, this is a sub URL. So it's going to be called users. So domain name / users. And then in here, we're going to do a post method. And we're going to create this function in just a moment. And then since it's a post method, we need some way of passing. Actually, no. We need a parameter for a get that I'm going to do. So let's start with the get. So again, when you receive the request, the database object is actually in there. So we're going to have this get call so that we can get the user object and retrieve their name and any other details that we might need. So in this case, we don't have an instance. We're trying to get an instance. So we're just going to use the model type. So once again, we take the current instance of the filter and we're doing a comparison. So as I showed you before, the 3 ways of getting parameters off of any request, it's going to be the query string, which is called the query object. Then we have parameters here, and then we have the content when you're doing a post back. So that's what we're going to do. And we only want one person. So again, we're going to throw an exception if it's not found. Otherwise, we're going to return that one person. So just for demo purposes, I'm not even going to use it in the sample, but just to show you another create. So in this case, I'm going to use the user just to show that it's possible to use the regular model if you want to. I don't think that that's a best practice, but it's totally doable if you want to. So then we're going to compile it. Now before we can run it, we do need to make one more small addition. Since this is a brand new controller, it's not been added by the template. Okay, so the compile was successful and we're about to run it, but before we can do that, I forgot to mention this. Inside of here, under options, there is a working directory, and it should be set to the root of the Swift Vapor folder. I did notice that I get some odd errors. I'm sure you saw this before, something about the working directory was missing, but it causes some other errors sometimes as well. So just make sure that you have that set up. And then we're going to run the server. So again, the sub URL is users, and then it takes a parameter as indicated by the colon. So we're going to add users and John. And then you can see that the entire object comes back, including the audit fields and the username and ID. All right, so we've pretty much gone over all of the basics. So what I'm going to do now is I have created this SwiftUI project. And since the focus of this video is the backend, I'm not going to show you all the code, or at least I'm not going to type it out. But basically, let me first show you what this looks like. No, I do not want an iPod Touch. Let's kill that. Okay, so I'm sure you've seen some of this stuff blink and get updated here. But basically what's going on is each of these three sections I have as their own view, as indicated here. So the first one is just showing who the current user is, then a form for being able to submit the user, and then a list of to-dos that will show up as they get populated. So this first one is going to be this guy up here. So all that I'm doing is I'm calling into our API server with a URL session, and once I get back the data, I'm just decoding it. So then you end up with John in this case. So obviously that works. And then, like I said, this is a form, and we're going to submit a to-do. In this case, it's going to be a post submit. And just revisit the create. So it's going to be this guy right here. Again, the to-do will have the association to the user. And then once it completes successfully, it will hopefully return whatever the result set is. But in returning that result set, it will kick off a reset of the list of to-dos, which is coming off of here. It's an observable object, which is acting as the environment object for the entire application. And this guy is simply going in and calling the get all. So every time a new one is added, the get all is called, and then get all is simply displaying them down here. So if I go in here and I say to do ABC, description ABC. So if this call is successful, then the set to-dos will get called. So then if I do YZ, and I just keep adding. So that's it. A quick introduction into Vapor. If you're really into Swift, and whether or not you do Android development as well, but if you're really into Swift, this is definitely a good way to continue using the language in your entire stack. There's opportunities obviously for code reuse. Maybe you can put some validation code, certain bits of business logic and stuff into some common project as a Swift package manager package, and share it between the two, the front end and the back end. So and from what I've seen, the system works really well. I mean, it's very well thought out. The list of dependencies, packages that you can use for various tasks is quite abundant. There's support for MySQL, there's support for Redis, sessions, there's GraphQL that I'm going to be doing on my second video. So at version 4.0, it's pretty mature. So you should definitely check it out. And once again, if you have any questions, leave them on my site, DzHaven.com, and I will answer them there.